In this video, I will show you how to choose which reason will prove that two triangles are congruent. There are 5 possibilities that work. We have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So as you can see, almost every arrangement of sides and angles will work to prove that two triangles are congruent, but here are 2 that do not work. Side-side angle does not prove that two triangles are congruent. So I'm going to put a big circle around that. That is a no, proves nothing. And the other one that does not work is angle, angle, angle. All right, having 3 angles that are congruent does not prove that two triangles are congruent. Now, I should caution you though, hypotenuse leg is actually a special case of side-side angle. So if you have side-side angle, but it happens to be a right triangle, then that's going to be a hypotenuse leg, which is fine. So let me show you what I'm talking about. Let's say we are given that angle A is congruent to angle E. So let's mark those congruent with a swoop. And angle B is congruent to angle D, double swoop. And segment AB, which is right here, is congruent to segment ED, which is right here. Okay, so can we prove that the two triangles are congruent? We have 2 angles and a side. So scan down your list. Which of these involve 2 angles and a side? Well, it could either be angle, side, angle, or angle, angle, side. It could be either one of those 2. Now, when you have a choice between angle, side, angle, and angle, angle, side, it'll be angle, side, angle when the side is between the 2 angles. See how the S is between the 2 A's? That means the side has to be between the angles. If the side is not between the 2 angles, then you will choose angle, angle, side. Okay, so which one is it going to be? Well, I can see that this side is between the 2 angles. So that tells me that this is angle, side, angle. All right, so I'm going to go ahead and put angle, side, angle. Let me just clarify. Here's how I know at a glance that the side is between the 2 angles. I have angle A and I have angle B. If you mark the vertices with dots, if you connect the dots, that shows you the side that is between those 2 angles. So you can see that the marked side is between angle A and angle B. Okay, now we need to make the congruence statement. So triangle ABC is congruent to triangle, and we need to match up the corresponding parts. So first we have angle A, and that corresponds to angle E. So we will start with angle E. Next we have angle B, but that corresponds with angle D, so angle D will come next. Last is angle C, which corresponds with angle F. All right, problem number 2. Angle A is congruent to angle E. Swoop, swoop. Angle B is congruent to angle D. Double swoop, double swoop. And side AC, which is here, is congruent to side EF, which is here. So which set of information do we have? This is very similar to problem number 1. Again, we have two angles and a side. So right away, that narrows it down to one of these two. It's either going to be this one or it's going to be this one. These are the ones that have two angles and a side. It just depends on whether the side is between or not. Now, in this case, all right, looking at this triangle, for example, here's angle A and here's angle B. If I connect those dots, that shows me the side that is between angle A and B. So you can see that the marked side is not between A and B. So that is why we're going to pick angle, side for the answer. All right, now let's do the congruent statement. So triangle ABC is congruent to triangle, and A corresponds with E, and then B is congruent to D, so that means D will be second, and C corresponds with F, because that's the only one that's left. All right, moving on to problem number 3. Angle A is congruent to angle F. So, single swoop. Side AC is congruent to side FD. And side CB is congruent to side DE. All right, now I'm noticing that we have two sides and an angle. This is the trickiest one because there are 3 possibilities whenever you have two sides and an angle. So here's one possibility. It could be side angle side, or it could be hypotenuse leg, because that's actually side angle as well. Or it could be this one. If it turns out to be side angle, that doesn't work. So in that case, we would put triangles cannot be proven congruent. But at first glance, as soon as I see that we have two sides and an angle, that means it's going to be one of these 3. Is this a right triangle? No, there's nothing here that tells us that we have a right triangle. There's no 90-degree angle. So that means it cannot be hypotenuse leg. So I can throw that one out. All right, so now it's either going to be side angle side or can't be proven. So here's how you tell the difference. If it's going to be side angle side, again, this is a situation where the word between is very important. The angle has to be between the two sides. Between. Just like you can see that the A is between these two S's. So if the angle is between the sides, that's the one I'll pick. If it's not, then that means I'm looking at side angle, which doesn't work, and I will circle triangles can't be proven congruent. So how do I tell? I think it's helpful to trace the two sides and see where they meet. So here's one side that I have marked, and here's the other side that I have marked. All right, notice that they meet down here. Okay, now notice that that is not the angle that we wanted. So that means the angle that we have actually marked is not between the two sides. So that means that this is side angle, and we'll have to circle triangles cannot be proven congruent. Okay, so I put between, so if it's not between, then that means it's this one. Okay, so the triangles cannot be proven congruent. So be careful. Do not put side-side angle right here. Never ever do that. Side-side angle is not one of the postulates or theorems that exists. So you should never write it down. Just leave it blank. Also, if you circle triangles cannot be proven congruent, do not make a congruent statement. Don't say triangle ABC is congruent to triangle EDF or whatever. All right, if they can't be proven congruent, then there can be no congruence statement. So both of these lines should be blank. All right, problem number 4. Angle A is congruent to angle F. Boom, boom. Side AC is congruent to side FD. Side AB is congruent to side FE. So I have two sides and an angle. All right, so this is very similar to problem number 3. So remember, whenever I have two sides and an angle, there are 3 possibilities. It could be side angle side, or it could be side side angle, which would mean can't be proven. Or it could be hypotenuse leg. If it's a right triangle, then that would be a possibility. However, this is not a right triangle, so it can't be hypotenuse leg. So I'm going to take that off the list. So it comes down to these. If the angle is between the two sides, then it's side angle side. If not, then it's side side angle, which is not a thing. Looking at the two sides that we have marked, here's one side, and here's the other marked side. Look where they meet. See how they meet right here? That is the angle that we wanted. So that means that the angle is between the two sides, which means side angle side is the answer. So now we make the congruence statement. Triangle ABC is congruent to triangle. Let's see, angle A is congruent to angle F. So that means F goes first. Okay, angle B. All right, so is angle B, will that be congruent to D, or does that go with E? Notice that angle B is connected with the double mark. So which of these is connected to the double mark? Angle E is connected to the double mark. So that tells me that angle B and angle E are congruent. So E goes next. And that only leaves D. All right. Okay, how about number 5? So on this problem, we need to consider some additional information. We have vertical angles here, right? Whenever you have an X being formed, the angles that are across from each other are called vertical angles, and they are always congruent, and you should mark them. So now, focus on one triangle at a time so you can really consider what you're dealing with. So if you look at triangle ABC, for example, you'll notice that we have 2 angles and a side. All right, now let's look back at our list. Okay, 2 angles and a side. So the possibilities are, okay, so it might be angle, side, angle, or it could be angle, angle, side. All right, those are the 2 things that have 2 angles and a side. If the side is between the 2 angles, it'll be angle, side, angle. If the side is not between, then it's angle, angle, side. So let's see which it is. Well, notice I have an angle here marked, and I have an angle here. If I connect them, it reveals the side that is between those two angles. And that is the side that we have marked. So the marked side is between the two angles. And we said that if it was between, then it was going to be angle side angle. All right, so this is angle side angle. So now, triangle ABC is congruent to triangle. A is first, and that corresponds with angle E. I can tell because these are both empty. And next is B. That's a single mark. That goes with angle D. And that only leaves angle C. So that is it for number 5. Jumping to problem number 6, again, let's go ahead and mark these vertical angles right away. Vertical angles are always congruent. Again, focus your eyes on one triangle at a time. So as far as this triangle goes, this is the exact same situation from problem number 5. So I won't analyze it too hard because we just did it, and we already know that this was angle side angle. So I'm just going to write angle side angle again. Now, the only thing that is different is we have the other triangle, we have a different side marked congruent, and we have a different angle marked congruent. That is only going to affect the congruence statement. So let's do that now. So we have triangle ABC. So start with angle A. Angle A, which is blank, must correspond with angle D this time. So this time I will start with angle D. Angle B, which has the single mark, must correspond with angle E. So angle E goes second this time. And then that only leaves angle C, so that goes last. Okay, problem number 7. Let's start by marking the vertical angles congruent. Now, they give us this additional piece of information. C is the midpoint of BE. So let's really focus on that for 1 second. So here is segment BE. So if C is the midpoint, they're telling us that this side and this side will be congruent. Okay, so now let's go ahead and focus on one triangle at a time. So let's focus on triangle ABC, for example. I see that I have 2 angles and a side. So right there, it narrows it down to either this or this. These are the ones that have 2 angles and a side. It'll be angle side angle if the side is between the 2 angles. It'll be angle angle side if the side is not between. But it is easy to see that I have an angle here marked. The other angle is here. This is the side that is between them, and that is the marked side. So the marked side is between the 2 angles. So that means we're looking at angle side angle. Angle side angle. All right, let's go ahead and make the congruence statement. Angle A is blank, which in this case corresponds with angle D, so that will be first. Next comes angle B, which has a single mark, which corresponds with angle E. That leaves only angle C. So that's it for number 7. Now, number 8, again, let's do these vertical angles, which are always congruent. So now they are marked. Okay, so C is the midpoint of AD. So this time they're telling us that AD, focus your eyes on AD. C is the midpoint of that. So that means that this side of it and this side of it will be congruent because C is the midpoint. Okay, now it's time to focus on one triangle at a time. So focus on triangle ABC, for example. We have two angles and a side. So again, that narrows it down to either angle, side, angle, or angle, angle, side. If the side is between the angles, it'll be angle, side, angle. If the side is not between the angles, it'll be angle, angle, side. So I see that I have an angle here and an angle here marked. If I connect those, it shows that this is the side that is between the angles. But the side that I have marked is not between the two angles. And like we said a moment ago, if the side is not between, then that's when we call it angle, angle, side. All right, let's do the congruence statement. Starting with angle A. Angle A is blank. That corresponds with angle D. Angle B has a single mark, so that corresponds with angle E, and that leaves only angle C. For problem number 9, we have a shared side now. Whenever you see a shared side, you know it will always be congruent for both triangles. So let's mark that. Now it's time to focus on one triangle at a time. So let's focus on triangle ABC, for example. I see that we have two sides and an angle. So that's the trickiest one because there are three possibilities for it. It could be side angle side, or it could be hypotenuse leg, which also involves two sides and an angle, or it could be side side angle, which doesn't work. And if that's the case, then I will say triangles can't be proven congruent. Let's start with hypotenuse leg. Hypotenuse leg only works for right triangles because that's the only triangle that has a hypotenuse. So let's see if that's what it is. Where is the hypotenuse? Well, the hypotenuse is always across from the 90-degree angle. So the corner of this little box is pointing right at the hypotenuse. So that tells us that this is the hypotenuse. Now, any side other than the hypotenuse is called a leg. So this is a leg. So what we have marked is a hypotenuse and a leg, which means that this is in fact hypotenuse leg, HL. So let's go ahead and make the congruence statement. Angle A goes first. That's the 90-degree angle. That's going to correspond with angle D. Okay, angle B is second. Angle B is touching the single mark angle. So I'm going to kind of keep that in mind. Well, you know what? It's going to be angle B. It's also called angle B in the other triangle. So I'm going to call this angle B. And then angle C is the only one that's left. Okay. Now, problem number 10. Again, we have a shared side, so let's go ahead and mark that congruent. And then focus your eyes on triangle ABC. Okay, again, we have two sides and an angle. So that's the one that has three possibilities. It could be side angle side, hypotenuse leg, or side side angle, which doesn't actually work. Let's start with hypotenuse leg. This is not a right triangle, so it cannot be hypotenuse leg. So I can kind of take that off the list. Can't be that one. So now it's going to be one of these two. And it's just a matter of the word between. If the angle is between the two sides, then it'll be side angle side. If the angle is not between, then that's side angle, which is not a thing. Okay, so here's how you tell if it's between the sides. Trace the sides. So here's one side that I have marked. Here's the other side. All right, look where they meet. The two sides meet right here. All right, this purple angle is the angle that is between the two sides because that's where they meet. But notice that is not the angle that we have marked. So this marked angle is not between because it's not over here. That means this is side angle, which does not work. So that's why we're going to circle triangles cannot be proven congruent. And when you circle this, leave the other two lines totally blank. Do not fill anything in here. Okay, moving on to problem number 11. Let's mark the shared side. So that's where problem number 11 runs into a tiny little bit of a twist because the extra piece of information is something we haven't seen before. Segment BC bisects angle ABD. Now, bisect means to cut in half. But to really visualize what's going on, whenever you see a statement like this, like something does something, you should start with the second thing. So start with angle ABD and trace that. ABD. So I'm going to go from A to B to D. So that is angle ABD. Now, segment BC bisects that. So we'll trace that now. So segment BC is this green segment, and that segment cuts the red angle in half. And so that means that we're going to have this angle will now be congruent to this angle. All right, because the green line is cutting the red angle in half, so each side will be equal. All right, so now that we have the angles and sides marked, it's time to focus on one triangle at a time. So let's focus on triangle ABC up here. Let's focus in on this. What do we have? We have two sides and an angle that are marked. Two sides and an angle. So again, this is the one where there are three possibilities. Two sides and an angle. It could be side angle side, or it could be hypotenuse leg, or it could be side angle, which doesn't actually work. Is this a right triangle? No, there's no right angle anywhere. So that means it cannot be hypotenuse leg. We can forget about that one. So it'll either be side angle side or side angle. If the angle is between the two sides, it'll be side angle side. If not, it'll be side angle, which doesn't actually work. So is it between or not? Trace the sides, and that's how you know. Here's one side that is marked, and here is the other side that is marked. Notice that they meet right here. They meet at the angle that is marked. So this is the angle that is between the two sides. So because the angle is between the sides, then this is a side angle side situation. Side angle side. Let's make the congruence statement you can see the symmetry, how the angles match up. So angle A corresponds with angle D. Angle B corresponds with another angle B. And angle C corresponds with angle C. All right, problem number 12. Here we have a shared side. So let's go ahead and mark those as congruent. And okay, BC bisects angle ACD. Remember, when you have a statement like this, start with the second part, angle ACD. Notice this is different than the previous problem. Angle ACD is this red angle. Now, segment BC is bisecting this, cutting it in half. So here comes BC, that's cutting the red angle in half. So on the previous problem, it was these two angles that were congruent. But on this problem, it's going to be these two angles that are congruent down here. All right, because we're cutting this angle in half this time. All right, let's erase these extraneous marks. And let's also focus on one triangle at a time. So focus on triangle ABC for a minute. All right, just focus on this triangle. I have two sides and an angle. Okay, so that means there are three possibilities. It'll either be side angle side, or hypotenuse leg, or side angle, which is not a thing. It's not a right triangle, so it can't be hypotenuse leg, so I can forget about that. So if the angle is between the two sides, then it'll be side angle side. If the angle is not between, then that's side angle, which is not a thing. So which is it? Well, let's highlight the two angles, and let's highlight the two sides and see where they meet. So here's one marked side, and here is the other marked side. They meet right here. So this is the angle that is between. But that is not the angle that we wanted. That's not the marked angle. The marked angle is way over here. So this angle is not between, which means that this is a side angle situation. But that does not prove triangles are congruent. So I will circle the triangles cannot be proven congruent. When you circle this, leave the lines blank. Okay, number 13. We have a shared side right here. Let's go ahead and mark that. We have extra information. BC bisects angle ABD. You want to start with the second part. Angle ABD is right here. ABD. Then BC bisects that. So that means here's BC, and bisect means cut in half. So the green line is cutting the red angle in half. So that means that this side is going to be congruent to this side. Now, focus on one triangle at a time. Focus on triangle ABC for now. What do we have? We have two sides and an angle. So that means that there are three possibilities. It could be side angle side, or it could be hypotenuse leg, which is also two sides and an angle, or it could be side angle, which is not actually a thing. So it all depends on whether or not the angle is between the two sides. If the angle is between the sides, then it's going to be side angle side. Otherwise, it's going to be one of these two. Well, actually, is this a right triangle? No, there's no 90-degree angle. So that means we can forget about hypotenuse leg. Okay, now, so it's between these two. So in order to figure out whether or not the angle is between the sides, you should trace the sides. So here's one side that's marked. Here's the other side that's marked. Look where they meet. They meet right here at the angle that is marked. So the marked angle is between the two sides. That means this is side angle side. Okay. Now, it's going to be really easy to make the congruent statement. Just look at the symmetry here. Each of these triangles are a reflection of the other. So you can see that angle A corresponds with angle D. They're mirror images of each other. So angle A is first, so that means angle D will be first. And then angle B corresponds with angle B, and angle C corresponds with angle C. All right, number 14. Here is the shared side. Let's mark it. BC bisects angle ACD. Start by tracing angle ACD. Start with the second part. So here's angle ACD. Now, segment BC bisects this. Segment BC cuts this angle in half. So that means this angle, and let me make it a little bit longer. This angle and this angle will be congruent. All right, these are the two halves that are equal. Focus on one triangle at a time. So for right now, focus on triangle ABC. What do we have? We have two sides and an angle. So that means there are three possibilities. It could be side angle side, or it could be side angle, which doesn't actually work, or it could be hypotenuse leg, which also involves a side, and an angle. But this is not a right triangle, so it can't be hypotenuse leg. So if the angle is between the sides, it'll be side angle side. If the angle is not between the sides, it'll be side angle, which is not a thing. Okay, to figure out whether or not the angle is between the sides, trace the sides. So there's one marked side, here's the other marked side. Notice that they meet right here. This is not the marked angle. That means the marked angle is not between the two sides. So that means we're dealing with a side angle situation. But side angle does not prove that the triangles are congruent. So I need to circle this. Whatever you do, do not write side angle. Leave this blank. In fact, leave both of these blank whenever the triangles cannot be proven congruent. All right, number 15. Here's a shared side. Boom. Let's mark that. But here we have the bisect happening again. Start with the angle that is being bisected. Angle ABD is right here. A, B, D. Segment BC is bisecting. So segment BC is cutting the red angle in half. That means that this half is going to be congruent to this half. You know what? I should use a double swoop since the single swoop is already taken. Okay. So these are the parts that I know are congruent. Now it is time to focus on one triangle at a time. Let's focus on triangle ABC for the moment. Okay, focus on that triangle. What do we have? We have two angles and a side. Okay, 2 angles and a side. So that's going to switch things up. So that narrows it down to these 2 possibilities. This one and this one. These are the 2 that have 2 angles and a side. If the side is between the 2 angles, it'll be this one, angle, side, angle. If the side is not between, it'll be angle, angle, side. So, is the side between the angles? Look, here's one marked angle, here's the other marked angle. If I connect those dots, that shows you the side that's between them. But this is not the side that is marked. The marked side is not between the 2 angles. So, since it's not between, that means this is angle, angle, side. Angle, angle, side. Notice the symmetry between these 2 triangles. The yellow and the white are mirror images of each other, and that will help you make the congruent statement. So obviously angle A corresponds with angle D, and then angle B corresponds with angle B, and angle C corresponds with angle C. All right, last one, people. This is a long video. But we have a shared side right here. Let's go ahead and mark that. Now we have the bisector. BC bisects angle ACD. Start with the second part, angle ACD. Trace it. Here is angle ACD. Now, let's trace the bisector. Segment BC bisects. So here is segment BC, and bisect means cut in half. So that means the 2 equal halves are here and here. All right, now we have everything marked that we need. So I'm going to erase these extra colors. All right, focus on one triangle at a time. So for now, let's focus on triangle ABC. All right, focusing on that triangle, what do we have? Let's see, we have 2 angles and a side. 2 angles and a side. So that narrows it down to either angle, side, angle, or angle, angle, side. If the side is between the 2 angles, it'll be angle, side, angle. If the side is not between, then that means angle, angle, side. How do we tell? Well, I like to put a dot on the angles. So here's one angle that we have marked, and here's the other angle. So if we connect the dots, it shows that this is the side that is between those 2 angles. But this is not the marked side. All right, the marked side is not between the 2 angles. So that means that this is angle, angle, side. It's not between. So angle, angle, side. All right, this has the same symmetry as the previous problem. So again, triangle ABC will be congruent to triangle DBC.